Hello everyone, welcome to the Module 4 of this course in Event-Driven Programming. This time we are going to discuss more on the programming with threads. The outline of this presentation will fall into the introduction to threads. Next is followed by programs that runs with threads. Secondly is we're going to discuss more on Java exceptions. So we are going to just skip for a while the discussion on threads, and we are going to discuss more on the running with threads. Okay, and next is we are going to the termination of different threads in programming. Okay, so now we are going to discuss more on the topic objectives, and you can see it here to demonstrate the ability to develop asynchronous programming and also implement a synchronous program using the threads in Java. Okay, so firstly, we are going to discuss more in the introduction of threads. By definition, what is a thread? A thread is a program unit that is executed independently of other parts of the program. So knowing that in development, usual programming are straightforward programming, which what happened here is their code runs from top to bottom. And with the use of threads, we are able to parallelize or to create a program that runs parallelly or runs at the same time. So it helps to make the code faster and the software much more faster in normal synchronous programming, because it makes use of different processor within the CPU, because the normal programming only use one CPU in the computer. Okay, so that is what thread is. And next one is we are going to discuss more on running with threads, so followed by this outline. Okay, but first I'm going to show you an example of an interface runnable. So what happened here is it's a interface type of class, which is it has a function that runs within its program. And what happened here is this void run runs into the thread. So this is a function that runs threads. Okay, so this next code here is represented in such a way that it uses a try-catch block. So whenever there are multiple threads that are being run, this is the code that is being executed in our threads. So to give you an example of threads, I'll just open to you a demo code in Java. Okay, so for example, we have here a class that is named greeting runnable. So this type of program make use of output or giving an output to a certain program, which we are going to simulate more on the different types of how threads runs and executes. So what you can see here is we are going to repeat this process, and we are going to output the time that the text has been called. So basically, the greeting here is the variable that holds the value that we're going to be interpreted, or that is going to be added a value from the instantiation of the greeting runnable class. So to give you guys a little background of this one, we can see here that there's a public void run. So what happened here is we are going to run this on the thread, which is from one processor to another processor, followed by a try-catch loop, which I'm going to discuss later what this does. And for this part, you can see here that there is a loop which indicated repetition. So the repetition is repeated 10 times. Okay, so next one is we are going to record the date on the time it was outputted, and we are going to system output, or we are going to output the result of the greetings. Next is we are going to sleep the thread. So what thread sleep happen here is it's actually a delay in milliseconds, so there is a 1 second delay. So we are expecting that when we are running two multiple processes at the same time, we are going to expect that the date and time will have the same value. Since in synchronous programming, we are expecting that there is always a 1 second delay whenever two values are being run. But this time, we are expecting that both of the timing of this class would be the same because it is run in two threads. So to simulate this one, I have already created here an instantiation of the class, which we supplied hello, and the other one here is world. So in threads, there's actually a syntax that we call thread T1. So thread T1 indicates here a process that is going to be run, which the process is the class runnable, which is called R1, which is an object of the class, which there are two threads here that we are going to run. And this time, we are going to start both of this function at the same time. So we should expect here that the result would have the same time. So let's just run this code. Okay, so what you can see here is we have exactly, okay, let's just wait for this. So it's a 10-second output since we added a delay. Okay, it has been successfully run, which you can see here that hello world or world hello. The world is the first one that has been executed. Okay, so what you can see here, it's both of this have the same time of outputting or the same time executing, meaning that this class or this object of the class and this object of the class run separately with two threads, which the other one runs to the other CPU and the other one runs to another CPU. Okay, so let's move forward with our discussion. Okay, now we are going to move forward in the discussion of Java exceptions. We all know that whenever that there are errors that's happening within the program, our program automatically disables or automatically closes. And that's something in programming that we wanted to avoid, that whenever there are errors, we are expecting that our software will continually run. So Java exception is something that developer uses in order for the system or in order for the application not to close unexpectedly. Okay? So but first, let's discuss more on exceptions. So exceptions is something that an error occurs within the method. It creates an object that hands it off to the runtime system. So in basic terms, this is just a block of code that instead of closing the application when there are errors encountered, there has been the error will automatically be sent out to the exception runtime system and output the error. So this is what exception is usually used. So, and I'll give you example later. And here is creating an exception object and handling it to the runtime system that is called a throw an exception. So throwing an exception happens when there are errors encountered. So instead of, again, closing the software or in closing the application, it just throws the error to the command prompt and identifying what the error is. Okay? And in programming, there's actually what we call Java exceptions, which is the try and catch. So again, it's an error that occurs. Java will normally stop and generate an error message. But in technical term for this is Java will throw an exception, just like what we have mentioned earlier. Okay? So there's actually what we call try catch. So try catch is a block of code that I have presented to you earlier that what happened here is it's something that, for example, that you want to try if the software would fail. So it's actually a programming paradigm or programming practice that you will always expect that your code would run in error, especially in running a database. So that's why try and catch is being used. So whenever there are errors that's going to be encountered, we know that our program will not close because of the try-catch block. Okay, so try statement allows you to define a block of code to be tested for errors. As I have mentioned, that's why what we call try. Try if there is an error or if the code will run correctly. Okay, the next one here is what we call catch. Now, for example, you have a wrong syntax in your code and you don't know actually what are you going to do, or you don't want your program to close, this is where the catch happens. So whenever there are errors, the block of code will automatically go to the catch statement. So the catch statement allows you to define a block of code to be executed if an error occurs in the block. So whenever there are errors in the code that you run, it will automatically proceed on the catch block. And finally, the finally statement lets you execute code after try catch regardless of the result. So whenever there are still errors within the try block or not, yung finally will still be able to run. Okay? To give you an example of this one. So for example, this is the syntax of the try catch block. So we have here a try keyword and we also have here a catch. And exception E is something that identifies what the exception or the error that had happened here in the try block. So to give you a further example of this one, I have created here a code of module 4. So first is we declare an array of numbers with content 1, 2, and 3. So for example, we want to try to output a number that is in the 10th index. But we know that there are only 3 indices here in this array. So we are going to expect that there should be an error and our program will close dramatically because there is no index 10. So the result, we will expect an exception. So when you say exception, that your code will have a runtime error, since based on syntax there's already an error. Okay, so again, and we don't want to happen this in our program, that whenever we run this code, our program will automatically close. So that's why there is what we call try and catch block. So try and catch block here is added on the code. First is the try, and then we add here the block of code. Okay, the same code. And again, we write here a catch statement. So when you say catch, whenever there will be an error, this block of code will be run. So for example, again, there's an error here. So from the try block, this will automatically go to the catch. So the catch will run the something went wrong, which this will be the output. Instead of receiving or terminating the code or the application, our program will automatically go here and will output the something went wrong. And that's really important in programming, that we will expect different errors, where we call this bug. And it's really important to have a try catch block in every program that we have, since in reality basis there will always be an error in our code. Okay, so again, for my last example, there is what we call finally. So the same code, we just added the finally, that regarding whether the code in the try block will run or not, it will still output the final result. That is how try, catch, and finally is being used.